Hi, welcome to Chapter 3, Part 1. We're going to finally get into some more of the nitty-gritty. Now that you've done Chapter 2, you know how to write a method, you know how to make robots move and snowmen turn and all that stuff. Let's make it a little bit more exciting. So we're going to talk about functions and expressions. So we've talked about storyboarding and putting it all together. And what we're going to talk about today is looking at the fundamental pieces of the program and show how to do it. So the fundamental pieces, there are four of them: instruction, control structure, function, and expression. You've already seen instruction. That's just a statement that it happens when the computer runs. So we've been defining that as a method, and you've seen that in action, and you've actually written some of these. So I think you're good to go with instruction. Control structure you've done as well. This is what controls which instructions are executed and in what order. And you might have guessed this is yes, do together, and do in order. Okay, so those are good to go. Functions, that's new. You've heard about it in math, but we're going to be using it in programming. So perhaps you've always said to yourself, what's the point? Well, now you have a good answer. Okay, so a function asks a question, and it either checks a condition or it computes a value. What we do in Alice is we look at properties of objects. So we'll ask the question, is the snow woman's face red? Instead of making it red, we'll ask if it's true. We'll ask about the relationship of one object to another. A current condition, for example, did a key get pressed? And then from that, you can use that answer to figure out what to do next. What we're going to do with this one is talking about the distance part, measuring the relationship of one object to another. So here's the deal. You're on a Hollywood movie set, and we're not sure. Is the pharaoh taller? That's the pharaoh, by the way. Or is the mummy taller? And how far away are they? See, these are pressing questions, and now good news, you know how to answer them. So we use built-in functions. A lot of objects, so you'll notice I clicked on mummy, and if you click on the functions tab right here, which is off to the right, you'll see some different properties. So proximity is one category of these properties, and we can ask these questions. These are the functions that come with the mummy. Values, so when you are using a function, then you need an answer returned, right? That's what's true in math. F of x gives you something interesting. Well, Alice gives you something more interesting, and that answer is called a value. What type of value? Well, it depends on the question you're asking. In other words, it depends on the kind of function. So we want to ask, what's the distance from the mummy to the pharaoh? What would you expect the answer to be? Well, hopefully you're saying it's a number, and we could get a whole number or a fractional value. Okay, great. So let's play this and see what it looks like. Okay, so here we are, and you can see mummy turned to face pharaoh. That's just a normal old method that you wrote. This is different. Mummy moved forward. Instead of a number, which you might have put in, there's something else. Well, where that something else is it's a function under mummy, so you can see mummy's details, and I clicked on function, and I can drag in mummy distance to, and anything that lights up green means it's going to work. So proximity will work in the place of a number. Just while I'm here, here are some other things. Size, so that could be a number. That would be weird to have it move forward its width, but you could. So that's another number. And spatial relation, this would be more along the lines of asking the question. So watch what happens, though, when I do this. So it turns to face pharaoh and moves forward that distance. It turns, and uh-oh, there's a problem. So we're going to talk about how to solve that problem. Do you have any ideas? Think about it while I pause and get us back to the PowerPoint. Okay, so what did we see? Well, we saw a distance to function. I showed you that it came along with the mummy. It's a built-in function that belongs to the mummy. And it helped us figure the distance from the center of the mummy to the center of the pharaoh, and that's important. And you'll notice I dragged it into the method, into the instruction. It wasn't standalone. It was one way to think about it is nested. Okay, so as we said, we used a function that had a number value, but there's some other possibilities. Some other values include Boolean, and this is true or false. It could be a string. Those are words. It could be an object, so that's kind of interesting. For example, snowman or helicopter. And it could be a position in the world. And frankly, right now we don't use that a lot. Maybe when you make up your own, you're going to want to use it, but for this course, not so much. Okay, so the problem you saw is that the mummy went right through the pharaoh. Not only did he collide, he actually went through it. So the difficulty is, and I was hinting at this, we've talked about this, the distance is measured from center to center. So if I say go that distance, basically it was trying to line up the mummy center with the pharaoh center. And that's a little bit bizarre. So you could just sort of subtract some number from the distance, and you could sit there and tweak the number and tweak the number and tweak the number. That's fine, that is an option, but that doesn't seem really all that elegant, does it? So let's do some math instead. See, it does come in handy. You can use math or a logic expression that's going to, logic operation that's going to act on numbers or other stuff. So Alice, good news, provides math, so the regular old multiplication, addition, etc., etc. And let me show you what that would look like. Okay, so you can see the difference here is that the mummy's now going to move forward the mummy distance to pharaoh, that's what we had before, minus 2. And I'm going to show you how to do it. I'm going to show you the whole thing. It's just it's a good thing for you to see. So I've grabbed the mummy and I'm dragging him here, and I'm saying mummy is going to move, and my option is forward. And this is important. Throw in any number you want, doesn't matter. And then we're going to go to the mummy's functions. So here's the mummy, here's the function, and I'm going to drag in distance to pharaoh. So here we go, clicking and dragging, and it's going to go right here, and it's going to be distance to the pharaoh, and it's going to be the entire pharaoh. But how do I get that minus 2? Well, check it out. You see this arrow right here to the right? Not the one associated with pharaoh, because that would change who it was going to, but to the right of it, I go down and it's saying, well, maybe you really wanted to put a number there. Nope, what I really wanted to do was put math there. So it's going to be mummy distance to pharaoh minus, and you can do whatever, 2 is fine. Okay, kind of cool. Here's another thing. I have my cursor over here, and I want it not to see this happen twice. So I'm going to right-click it and disable it. And that just means that the computer won't see it, but I don't have to erase it in case I'm really proud of my work and I'm just not sure when I might use it. Okay, so if I hit play, watch what happens. He turns and it's a little bit less. So yeah, it works, but again, it's not so elegant. So how can we make it elegant? Well, okay, so again, I showed you how to create a math instruction, and the available math operators are the usual suspects. Okay, now what I want to do is, what I wanted to do was show you another version where instead of it being mummy distance to pharaoh minus 2, they said, well, what if you subtract the pharaoh's width? We'll take a look at what that looks like first of all. Okay, that's pretty darn close, right? So where does that pharaoh's width come from? You click on pharaoh, you click on its function, so you can see all this stuff, and this is what you would drag in instead of the number 2 that we had before. Very exciting. Well, that's one way to do it, and I want you to think to yourself, as I pause again, why that worked. Okay, so do you know why it worked? Well, again, just what we did is before I said 2 was just kind of random, so instead we're going to do subtract the width of the pharaoh, and you might want to draw a picture of that and say, all right, well, that would kind of work, but it'd be a little bit weird. Let me go back to our original drawing, and I'll show you what I mean. Okay, so I could do this distance minus the pharaoh's width. Well, the pharaoh's width is this whole thing. So it might work, but it sort of doesn't make a ton of sense. Wouldn't it make sense if we included part of the mummy's width? So if we got rid of this piece right here and this piece right here? And wouldn't you describe this as half of the mummy's width and half of the pharaoh's width? Yes, I think you would. And so here we are again. You can see this line is getting more and more complicated. And in fact, let me play it for you, and then we'll talk through the math of it again. So it turns, and perfect. Okay, and so what we did is the distance that we talked about, so from here to there, minus, and watch all these parentheses, isn't that crazy? So this, the pharaoh's width, plus the mummy's width, all of that divided by 2. And again, all of this gets figured out by messing around with those arrows, and you can first do, the distance to the pharaoh, and then you can do the distance to pharaoh minus 2, and then you can stick in these other things, and again, they're under the individual functions. So it's mummy's width right here, and it was pharaoh's width, and then you just keep pulling down on these white tabs to do some math. Okay, so that's the idea. And one more time, let's admire it in its beauty. it turns and it goes to just the right place. Who knew it was so complicated to have it go just from one spot to another? So to be even more precise, like we said, we subtracted half of the sum of those two widths, okay? And it gives us a very close estimate of the distance to move. And we talked about it a little bit, but you want to be super clear on that, just in case, oh, I don't know, it shows up on a quiz. All right, go think great thoughts. Enjoy.